Hello everyone, so today I will present the MAT523 Linear Algebra 2 group project with the title of Hand, Foot and Mouth. Our team members consist of Nur Amira Izzati, Dayang Nurjeha, Pamela Ember, and Nur Aina Kamila. So this is the content overview on what we are going to present in our slide. First we have the introduction, next we have implementation on the quadratic model, then we have the graph, which is the quadratic model as well, analysis, and also last but not least, we have the conclusion. So I will start the presentation for today. So in this slide is the introductions of our group project. Hand, foot, and mouth disease, which is better known as HFMD, is the common viral infection among children spread through contaminated surfaces and respiratory droplets. In 2024, Malaysia experienced a surge in HFMD cases, with Selangor reporting the highest numbers, followed by Johor, Perak, Kelantan, and Kuala Lumpur, along with Putrajaya. Many cases stem from outbreak clusters in childcare settings, emphasizing the need for better prevention. Our study aims to analyze the relationship between the years 2015 to 2024 and HFMD cases in Malaysia using a quadratic model. The table on the right shows the years from 2015 to 2024 and the number of HFMD cases in Malaysia. Hand, foot, and mouth disease, which is HFMD, has been recurring health concern in Malaysia. Let's take a closer look at the trends over the years from 2015 to 2024. From 2015 to 2019, HFMD cases show a steady increase, peaking in 2019 with 51,115 reported cases. However, the onset of the COVID-19 pandemic in 2020 had a noticeable impact, reducing the cases to just 8,788. In 2021, cases dropped even further to 4,239, the lowest in the decade, likely due to the strict health protocols and limited social interaction during the pandemic. However, as restrictions eased in 2022, HFMD cases skyrocketed to 106,477, marking the highest number recorded within the decade. Following this surge, cases gradually declined in 2023 to 9,822 and further dropped to 3,446 in 2024, indicating effective control measures and public awareness. So, as a small conclusion, understanding these patterns help us prepare for future outbreaks. Continuous vigilance in public health interventions remain critical in controlling HFMD in Malaysia.
Assalamualaikum and hello everyone. My name is Nur Aina Karmila binti Mazlan with the student ID number 2024235146, and I will be presenting the implementation of the quadratic model. The least square fit of quadratic is y equals to a plus bx plus cx squared. As you can see in the slide for number 1, the first matrix represents the matrix A, and the next matrix is our B, and it is equal to matrix B. Then, we will write it in the normal equation, which is in the form of A transpose A multiplied by B equals to A transpose B as shown in number 2. Next, we will find the least square solution using the formula V equals to A transpose A to the power of inverse multiplied by A transpose B. Then, we will get the answer for the value of A, B, and C. Since the best fit quadratic curve is y equals to a plus bx plus cx squared, we can conclude that the best fit quadratic curve is y equals to negative 363394907529 divided by 110 plus 4319791757 divided by 1320 multiplied by x minus 213959 divided by 264 multiplied by x squared. Next, we will find the error vector using the formula of E equals to B minus AB as shown in number 5. Lastly, we will use the value of the error vector to find the magnitude of the error vector, which is 1 over 330 multiplied by the square root of 88671 291 014 7735.
Assalamualaikum and good morning everyone. My name is Nur Amira Izzati. My student ID number is 2024694314. Today, I will present about the graph of the quadratic model that we've got from the maple. As we can see, this is the graph that we've got. The graph illustrates a linear regression model that's showing the relationship between years and number of HMFD cases in Malaysia. The data points are fairly scattered around the line, indicating that while the trend exists, the line of the best fit curve that indicate a positive linear relationship. While the year increase, number of HMFD cases also increase as well. Next, the slope of the line is relatively mild, which could imply that the impact of year on number of HFMD cases is not very strong. Other than that, there's some point lie far from the line of the best fit, potentially represent outliers. This might indicate which HFMD cases do not follow the general trend, possibly due to other influencing factors like how people take care of their hygiene or general knowledge to community about HFMD. Okay, next. So this is the residual versus X graph we've got. Based on the figure, the points are randomly scattered and there is no visible pattern or trend that show the quadratic model represent the relationship between years and number of HMFD cases. The number of cases appear to be scattered randomly above the zero line, which suggests that the quadratic model capture the overall trend well. The residual are evenly distributed, indicating that the model's prediction align well with the actual data. Thank you.
Hi, my name is Dayan Nujah Shafika binti Muhammad Nazri with student ID 2024-235.18. So, now moving on to the analysis of our findings. The quadratic model that we applied gave us an error magnitude of 90235.53. This tells us that on average, there is a moderate difference between the actual number of HFMD cases and what our model predicted. So, if we look at the residue plot, we can see that the residues are randomly scattered. This is good sign because it means the model fits the data fairly well overall and there's no obvious patterns or bias in the errors. And one of the most significant observations is the sharp spike in HFMD cases in 2022. This could be due to several external factors such as changes in hygiene practice, increased awareness, or improved reporting following the COVID-19 pandemic. And after that, we noticed a decline in 2023 and 2024, which might reflect the natural variation in disease outbreaks as conditions change. However, we also identified outliers between 2020 and 2022. These points don't follow the general trend, suggesting that there were other factors influencing the number of cases that were not accounted for by our model. So, overall, while the quadratic model gives us a good approximation of the trend over the 10-year period, it doesn't fully capture every fluctuation. This shows the limitation of using a single variable model in real-world data analysis. So, the conclusion, the quadratic model successfully captures the relationship between the years 2015 until 2024 and the number of HFMD cases in Malaysia, showcasing fluctuation with notable peaks and declines. Significant outliers may reflect external factors such as public health measures, awareness campaign, or hygiene practice. Residues analysis indicates that the model aligns well with the actual data, making it a reliable tool for understanding and predicting trends in HFMD cases over the years. This insight underscores the importance of targeted interventions to manage future outbreaks effectively.